All right, welcome to coding challenge number 3, solutions. As you know, I've been giving weekly challenges. It's on our website, scienceoftechnology.net. If you haven't been there, just feel free to go. Let me pull this window here so you can have a look. So go to our website. We have been doing training since 2008, 17 years. Hundreds and thousands of students have gone through these training programs. So you go to events and meetups, and here you can go to weekly coding challenges, and of course you can join our weekly meetup that happens specific time every Thursday, 7 p.m. to 8 p.m. So go inside the challenge here, and you can see the questions for this week. So we had 3 sections: basic Python challenges around sum of digits, creating remove duplicates from a list. Let me make this window a little bit bigger in case you have difficulty seeing it. So second, removing duplicates from list, temperature conversion, merge dictionaries. Really straightforward. So you should try to implement them. If you're not able to solve them, then you should look at some of the good books on Python or contact us for training programs. And then I had few intermediate Python challenges around longest common prefix, summing numbers from a file, stack implementation using list, and I'll walk you through that as well. And then there are questions around machine learning and data preprocessing. Especially this time I chose imputing missing values or encoding, outlier detection, and handling duplicates. And after every week, what I do is I move these coding challenges to the repository section. So when you come back, maybe next week, you can see a new link for challenge number 3. For example, you can look at challenge number 2 right here. With that, let's go back to our deck very quickly. So, we talked about basic Python questions. We talked about intermediate Python. So let's walk through them first. So there are many ways you could have written this code. You can use Anaconda Jupyter Notebook, which is I generally use. But I also wanted to show you how to use Cursor IDE. That's also very useful. So nowadays, I either use Cursor IDE or Anaconda Jupyter Notebook. Or if I'm working in AWS, then of course I'll have AWS SageMaker Jupyter Notebook. Or in some cases, I might use Google Colab notebooks as well. All right, first question, sum of digits. So write a function that calculates the sum of the digits of a given number, like 4, 3 would return as 4 plus 3 equals 7. It is fairly straightforward. So what I have, there are many possible implementations. Implementation I chose, I took 43, I converted that in a list, and list, the digits will I get back is a list of which has 2 values, 4 and 3. So if I print it, for example, digits, start the Python environment, then you will see, and of course, when I will be calling, so I have the class sum of digits, I have a function sum of digits here, and here, I am taking the input number, converting the list, and I'll print it like when I make the call, in fact. Let's see. So when I call 43, you can see the list which I'm getting back is this 43 here. And then the sum is 0. And as I get to the digit, so for digit and digits, so first time I'll have 4, so 0 plus 4. So sum is now 4. I go to the loop again, and 4 plus 3 is 7, and I'm returning sum as 7 here. So very straight, like a simple problem to solve. And then as I talked before, I always encourage you to use some kind of testing framework. Here I'm using IPyTest. Here I'm making a call. So the first thing you do is you create a test function, and then here I'm asserting that if I pass 4, 3, the value will be 7. And then I go and run the IPyTest.run. And here saying the value is that the test case passed. For example, like, if I was expecting 87, which is incorrect, and that's what I'm going to show here, you will see when it runs, it will give you an error saying that the assertion fails. So very important tool for you to know, the IPyTest or any unit testing framework in Python, because when you're writing tools or code, you definitely want to make sure your code is unit tested. All right, so that was number one, summing of digits. 43 will become 4 plus 3 equals 7. Let's look at number two, removing duplicates from a list. So the idea is, like, if you have a list like 12, 12, 7, 8, 8, 9, 12, the two values are 12, so I want to remove 1, 12. Or same with 8. So I want to get 12, 7, 8, 9. 12, 7, 8, 9. And I want you to preserve the order. And this code is like also fairly straightforward. So the way, again, there are multiple implementations. The way I'm writing it here is, I'm trying to maintain the list with unique elements. So for element in input list, this is the list I'm passing here. So I got, let's say, 12. So I'm saying if my element is not in my unique element set, which is empty to begin with, then I am adding that element to this list here. And I'm also appending that element to return list. So if you think a little bit here, so if I get 12 the first time, is 12 in my list with unique elements? No. So this is where, like, this becomes true. So list with unique elements dot add 12 now. So this has 12 now. And then I'm also returning, I'm appending that element to return list 12. So this is also 12 now. And now it will be interesting next time. So if element not in list with, so next time I got 12. So now I already have 12 in list with unique elements. So when I come here, if 12, because it's in list with unique elements, this becomes false. So I completely skip it. You see that? So because I already have 12 here in this set. So next time when I come here, because I already have 12, I do not include it. So then I go to 7. 7 is not in this empty list. So I first include it there. And I also include the list I'll return, 12, 7. Let's come to 8. The first time when I come to 8, it's not in this list. So I will go append here. I'll also append here. But look at this second time. When I get 8 again, 8 already is in this list with unique elements. So this will be false. So no action will be taken. So I will not be adding it either to list, because it's already existing, or I will not add to the return list. And that's it. Like, so this time, so you get 12, 7, 8, and 9 in this question. So if you want to look at, pause your video, look at this solution a little bit more, see if you can write something similar, and then test it. So I create an object of remove of duplicate class, then I call object.remove duplicate, and I get the value 12, 7, 8, 9. And from here, I have again a test. This is a copy paste, it's not test, is prime. I mean, you can call anything, but I want to call it something meaningful. So I will do test remove duplicate. When you run it, it just passes. So guys, very straightforward. The trick really here is that you start with this list and keep a track of the numbers you have seen. This is what I'm maintaining, a list with unique elements. If you have seen it already, then do not add to your return list. If you have not seen this number, then add to your return list. And that's how you get 12, 7, 8, 9. All right, number 3, temperature conversion. Very standard, like this is the programming 101 for any language. There are a few things which are straightforward, but there are a few things I've added to give a little bit like the more spice to it. So the first, like, if I pass Celsius, if I don't get Fahrenheit, that's the formula. Celsius multiplied with 9/5 plus 32. This gives you the Fahrenheit. What I have made a few small changes. So I wanted to format in certain ways. I want to look at 2 decimal places. So I'm saying format 0.2f. And if you do format, that gives you string value. And I want to get a float value back. So I'm again encapsulating that under float. So this will give me float with 2 decimal functions. And same for Fahrenheit to Celsius. This is the formula, Fahrenheit minus 32 multiplied 5 by 9. Skip the environment. And for validating this, I instantiate the object, call the method. So if I pass 40 Celsius, it's 104 Fahrenheit, and also 75 Fahrenheit is 23.89 Celsius. And this, is commented out for the first time when you're trying to install IPyTest, and you need to uncomment this and run this. And coming back to the test here, again, I could have created like 2 test methods, one for Celsius to Fahrenheit, one for Fahrenheit to Celsius. I just created one, but I think when you're writing code, you should create 2 test cases, one for test Celsius to Fahrenheit, and just do this assert, or I can just write it with you while we are here. Celsius to Fahrenheit. I like giving meaningful name to my functions, so when you're looking at this later, you're not confused what this function is trying to do. So I have 2 test methods there. I run them, and they both should pass. Is 3 because it also considered the first one. If I do not want 3, so it's simple. You restart your runtime environment, and then you rerun all the steps. You can also do Shift Enter. It's a shortcut. We come here and we do that. So it might take a few seconds while it's starting. Object is not defined because probably we did not run in the right sequence. Let's go. Oh, I know why. Because when we create this new methods, these objects which we are calling for these functions, we probably deleted them. They both passed. So that was our number 3. Number 4, merging dictionaries. There are multiple ways you can do it. I use an inbuilt function here. So merge dictionary is my class, and the idea was like if you have A1, B2, dictionary 1, and second is B3, C4, the output I will look at A1, B3. You can see the key B has value 2, key also has value 3. I want to put the value from the second dictionary here. So B is 3 and C is 4. So merge, you pass both dictionaries. The final dictionary, I'm saying, okay, make a copy of dictionary 1. And then I'm saying final dictionary update with dictionary 2 values. And it, this is an inbuilt function. But if you had to write it from scratch, you can also do it. You start with this dictionary, iterate through it, go element by element. If you don't see in the second one is fine, but if you see the value like here, B, in the second one, you take the value from the second dictionary and populate the value for this key. So yeah, this is what I like about this, this, if you're able to write this, it also illustrates your strong grasp with the dictionary functions. And then, of course, we go through this testing part. Let it run. And that will pass all done. IPyTest, I think I deleted import. maybe some copy paste, and then you run the IPy test functions, and then this test merge passes. Cool. So they were our basic questions. Let's go to our next set. There were 3 questions here for intermediate Python. Longest common prefix, talk about that. Summing numbers from file. Here, this is not really difficult. If you haven't worked with file read or write, this will help you get your skills refreshed in that direction. And then the hard part or non-standard part really was how to read from a file, which is really 1 line of code. And then stack implementation using list. This also, it looks hard, but it is not. Like, for example, if you're trying to push something on a stack, you just add appending to the list. Or if you're like popping something, you're just popping the last element from the list. We'll go through that code in just 1 second. So let's go back to our longest common prefix. So for example, artificial intelligence, artisan, article, articulate. The prefix here common for all of them is ARTI. So, there's some, I was trying to debug something to see if my code was right. So I was printing some of the print statements. So the idea here is like a class, largest common prefix, get longest common prefix here. You get the list here. If the list was empty, then I'm returning prefix is really nothing. The string value has is an empty string. Otherwise, I get my first element before. I'm glad I did not discarded this code because it's an interesting piece of code. So there are multiple ways you can do it. What I've done is I am sorting that list first. So when this comes in, I'll sort them. And that's what I was trying to print here. I want to show that to you. I will sort this list, and then let me just run this part first. So I'm going to show you something before I go in the code. So if I pass artificial intelligence, artisan, article, articulate, and if I say sorted that list, that will come really in the alphabetical sorting, like article becomes the first element, and artisan, because S comes after C, becomes the last one. And once I sorted, my work becomes very simple. So what I will do is I'll take this word, article, the first element in the list, and the last element in the list. I will go through character 1 by 1. If I say A is here, A also is here, definitely, then I'll add running prefix is A. I'll look at R also is here, so then I'll add AR. I'm here, ART, ARTI, so now my prefix is ARTI. But when I come here C, and I don't see C here, so I know that my prefix, that was my prefix. I do not have to do anything. I can break out of the loop, and I can return my prefix is ARTI. So first element I took, input list 0. So that gives me article. Input list -1, that's the last element. I get artisan. And you will see actually this format a lot in working with generative AI, because when you're talking to an LLM, you always it's a request response. You're sending a message to the LLM, you're getting the response, and it's a conversation. So you might have 20 messages. You'll often see that you'll do -1 to see the last message. So this pattern you will see repeating a lot. And that's why it's important to work on some of the fundamental coding as part of this coding challenge, because this will become very handy later. And also, okay, so I am going to iterate through the loop. So for I in range, so I took the minimum of of first or last. For example, if this was only I don't know, 5 characters, there's no point going through this 20 character, and that will, in fact, it will be incorrect also, because if I go to 20th index, it is only 5, it will go array index out of bound exception. So I want to look at the minimum length of 2. Then the same code, like first ith value, like first 0th value a is the same as last ith value 0. If it's same, then I think that return a string, this prefix a string that needs to include that. So I'm saying return a string plus equals that value, and I go through that loop, I get return a string, and I'll go and run this, and you'll see this passes. So here assert arti equals longest common prefix. So I think when you go to interviews and look at some of the coding questions, even if they can look complex, you just need to slow down and see what will be a good approach to solve it. And most of the time, if you spend like few minutes thinking about it, you will know the right approach. All right. Summing numbers from file. So for this, I have created a file here. Let me get that file. Let me create open my. Give me a moment. I'm trying to get the file so I can show you the data structure. I am navigating to my folder. Almost there. This is my data numbers.txt. Let me open that file, move it to this window. So I have numbers like 2.0, 3.7, 6.4, 8.2. So the logic is simple. You don't take a number and just keep adding them and get the sum. The slightly tricky part really here was the file read. If you haven't done that in Python, that might be new to you. So that's why I put this question here. And again, I have a class, I have a function get number sum, I give the file path, and the way I'll be calling this like get number sum, I'll pass the file path here. And file path, what you need to know, with open file path as read mode as file. That's the only thing, guys. It's as simple as that. Once you file, you can iterate through every line in the file, for line in file. And once I get the value, so first I take the string value, convert to float, and I add them as sum, and I return the sum. So again, I'll say the code itself is very straightforward. Here, the new information really was how do you open a file and read a line from there. Or if it could have been the same line also, comma separated, then you need to say, like how do you read a character or delimited values at one time. I can give that in the future assignment. Or if you're feeling really happy, then you can write, like change this code a little bit to see how will that look if your numbers were more like in the same line and not different lines, something of that sort. So if you can do it, put that in the comment. I would like to see how you did it. Okay. So I'll revert it back how it was. And then stack implementation with list. And again, I just limited to push, pop, and size. And this looks scary, but it is not. I can tell that. So like I have a class stack implementation using list. I have initialization. The first thing I have a local variable list representing stack. I could have called just list here. That's empty. So the way we'll use it, the first time we'll be calling the object. So we call the object or build the object, instantiate the object. At that time, we will be putting list representing stack as empty. And then we'll start pushing values. I'll push an item, value here. So in that case, I'll say I'm just appending as a list, right? So I'm appending to the list here that item, right? And I'm not really, this is not really needed. But if I wanted to return, I could have returned. So you can see at that time. And the same for pop, right? So pop, I will get the length of the stack, and I'll get the length minus one, the last element. I will return that. In fact, there are other ways I could have written also. I basically am reducing the length of the list by one. So you can see the list representing stack is from beginning to length minus one. So the last element is basically lost. And that's what I'm returning. And that way, this is one way to pop a value. And then if you look at size, I'm just getting length of that list and return that length. And there are two special methods, a few more. If, for example, coming from any programming language like Java, you need to override toString method and equals method. So here we have special methods underscore underscore str underscore underscore. And then here I'm returning the object itself. But you could have written a few other formats too. Any format, here I'm just returning the list itself. But if you wanted to be fancy and change this implementation anyways, you can do that too. And equals here, I passed another list. So I say, okay, is this my current list same as the list I passed here? So here, in this example, I create a list, push 5. After pushing, I get 5, and I push 7, so I have 5 and 7. Then I pop, so at that time the size is 2. I pop it, so now the list is 5. If I wanted to see the size, I can also do that. So size now is 1. Very straightforward. And then you run this. This is how you typically write unit test cases in production environment. You have test underscore push. For every method or function, you create a test method. So test push, test pass, and test size. And then you run it. So if I run it, I'll see all 3 test cases passed. So that covers our basic Python and intermediate Python. Let's go back to our deck for a second, see what is there. Just like a quick reminder, if you have come this far, please like and subscribe. We'll be publishing new solution every week. Or if you're looking for any kind of training, just go to our website, scienceandtechnology.net, and you can see training programs which are available, and you can sign up there. All right, the last section, machine learning and data preprocessing. I put solution around impute missing values using mean and median or KNN imputer. If you are dealing with any kind of data science project, this is going to be very critical. Then we have categorical variable encoding. You always, well, not always, but most likely will get categorical values in your features, and you need to know how to encode them in numeric values so you can impute. For example, if I have a value for, let's say, gender, and gender value is missing, you cannot really impute missing value. I mean, you can drop it. Sometimes it's okay to drop, but if you do not have a lot of data, then dropping, you have to be very careful how and why you're dropping a row or rows. And then outlier detection. So you can also sometimes the outliers can skew your data, so you may want to detect and remove them. And there are multiple ways you can remove. You can look at the IQR interquartile range method and a z-score method. And then sometimes you have duplicates. What do you do with duplicates? Like, how do you remove them? So I'll be showing all of them to you. So I packaged everything in the single file here. So I have a file. Let's see, open with. You can see it here. Like when I load, you can see the output. So, or the raw data. It's not a super big file. It's 15 rows. And you can see there's some missing values, which I would like you to work on. You can also see there like categorical values like education, membership level. So I would like you to change and gender. This part of the assignment. So import pandas as PD. and then you read the CSV, very standard stuff, data head, it will give you 5 rows from top. So impute missing values. So the first thing you always need to do when you work on any AI ML project, first you need to know how many of the values are either null or not available. You will see that the data frame has two methods, is null and is NA. The reason it is because is NA. If you already know the answer, if you think you know the answer, just put in the comment. But if you do not, or if you want to see my explanation, the reason is NA happens because some of the other libraries they have similar methods. So initially Python has had is null. They changed it to is NA to be consistent with other libraries like R. Um, and that's the only reason. So you can use is null or is NA. I like using is NA because consistent with other libraries in data science space. You can see there are 4 values in age, which are have null values for income to education to spending. And for education, I had to do something special later. So like I wrote this here because I was looking for the values, how many bachelor, what are the unique values like, and um, I'll come to this just in a minute because I'll explain something. So just ignore this for now. We can see here coming back to is NA 4 null for age, 4 for income, 2 for education, and 2 for spending score. Just ignore this for a second. I'll come back to it. So I just made a copy, like of original data. In case we mess it up, I can always go back to data copy and copy it again. So the first thing, right? So age, as you can see in head also, like some of the value. This is like a missing value. So what do you do if you're trying to impute value? Impute meaning trying to populate a missing value. You have few options. You can get the mean here. You can get the median. You can use the KNN imputer. So the KNN will tell like based on like this data row, like what's the nearest, is unsupervised learning, what's the nearest possible value. Or you can even drop this. So depending upon like how it is your data set, I have only 15 rows. If I drop one, there's a big percentage being dropped. So I definitely do not want to drop and look at other options. So for example, I can take data age. I'll get the series of all the ages, right? And I'm saying fill NA. If it's not available value, fill it. How do I fill that value? With the mean of the data age series. So it takes basically all the values, takes the mean, and that mean will be populated here. And then I did a little bit like np.floor because when this happens, it likely was going to be in fraction. And just looking at the values, all the values are whole numbers. So I just put np.floor, so I'll get the smaller number. So once this runs, you will see for the missing value, you can see here as a nan, right? For customer ID 104, the age is NAN. For 104, this will turn out to be 38. That's the average. And then same for income. So income, I'm saying, okay, fill NA data incomes, the mean of the income column. And I'll do floor. I just did floor because this likely will come as a fraction. So I wanted to see, numbers as like a whole number. And then spending score. Spending score also the same thing. Like I'll take the median. So here in place of mean, I took median. And depending upon data, you will have to really think, do you need a mean or median? I wanted to use just the midpoint in a spending score, so I put it, but it could have a mean also. Or like other things, like you could have a mode. So you have to be thoughtful about why or what is happening, and that will generally be dependent on the type of problem you're trying to solve or type of data you have. So once I run it, you get the values populated. So last time, for example, we saw some nans like spending score over NAN. This was NAN we saw. This became 38. Income also. So change. So income became 868692, and then spending score became 53. But education is different. So education is a categorical value. It's basically all strings. I cannot get a mean, median, or anything of the string. So first thing is I need to convert that in some kind of number system. So education, I'll say, is an ordinal categorical value. Ordinal meaning there's some order, like high school is of less value compared to bachelor, which is of less value compared to master, which is of less value compared to PhD. So I gave the levels 1, 2, 3, 4. And the interesting part here was like, how do I know how many values are there? And this is where I wrote this line, data education. This gives me the education column from data frame. And I grouped by education column, and I'm looking for value counts. That's why it's like returning. And if you wanted to see like, the entire data set, you can remove it and you can see how the data looks like. So here, so I knew the value came as high school, bachelor, master's, PhD. So I copy pasted them here. So this is my map. So I'm saying data education. So you will see that this data education itself, it just gives you cities. So I get this cities here: education, bachelor, master, PhD, bachelor, master, in a bachelor here, right? And then you say map education order. So what this will do, it will go through this series. If you see the value bachelor, it will return the value for this row as 2. This cell is 2. If it's a master, this cell will become 3, and so on. And I'll assign that to data education. And I don't need the floor here because oh, I know. Yeah, okay. So this step gives value 1, 2, 3, 4, right? So these value 2, 3, 4. But then if I look at a missing value, if I had a missing value for customer 113, so let's look at data here quickly. 113, yeah, 113 has education as nan, not a number, right? So I go there and I say, okay, data education, fill not available with the median number. And median will pick up the middle point. So I don't really need a floor here. But if I was dealing with, let's say, mean, floor would have been helpful. And I'm trying to print the value for 113, so you can see what the value is now for 113. Okay, and you can see the education is 2.5. Now, and floor is fine because it just happens that probably the odd number of rows are 15, so it got the middle value, and that was like fraction. So this gets messed up because the last step already had converted them to numbers, and this time when I worked on education column, there were no values with high school bachelor. That's why that failed. So if you're trying to convert, you have to be careful. Like if you already have converted a value, let's say the value was bachelor, you already have converted to 2.0. And if you apply your logic again on that converted, because you're running this twice, so that can mess up your, the logic, because now when it looks at bachelor, it says the value is 2. It's trying to map your column, so it's looking at bachelor or one of these values, but the value is 2. So it just like cannot find the mapping for 2.0. So it will make it nan again. That's what happened last time. And if I run it one more time, this is what will happen. Let's say, see here, everything became nan because it already was converted. It's trying to map to these values, and those values like bachelor or master do not exist anymore because they were converted to numbers like 1, 2, 3, 4. Okay. There are other ways to impute missing values also, and this is one of my favorite Canon imputer. So again, I had the copy, so I got the data frame again, and here I'm saying the same code. I took education order, and I converted them into because I had to do this again because I made a copy. I made a new copy of data. So whatever work I did was lost, and I wanted to show a new concept. So I wanted to start scratch with from beginning here. So the tricky part here is finding the two types of columns. If you go back and say they're numerical values, they're categorical or alphanumerical values. So I'm saying numerical columns say data.selected data types include np.number columns. This gives you all the columns which are number type. A non-numeric value will be, I just put the exclude. So it's excluding all the number types here. And then imputer, like KNN imputer. Here you can set how many nearest neighbors you want. I just put 2. You can put 3. We have a small data set, so I just put 2. But generally you can put 3 or 5. And what this imputer metric does, imputer, that's the KNN imputer, dot fit transform. It will fit your data and transform it. Data only for the numeric columns. If it's alphanumeric, we'll do something different about them. So this is trying to impute only the numerical values. And once we have it, I get the imputed data. I build a new data frame based on the imputed numeric values we got, and for these columns, for the numeric columns headers. And then I go back and create a new, a new data frame where I concat the imputed data with numeric columns data. And then I reset index, drop them on the axis equals 1. So what you get is the new data frame where you can see all the numeric values are here first because you're concatenating the numeric ones first and alphanumeric later. And then when you go back and look at a sum of what's missing, nothing is missing now anymore. So it's a great success. We already have come long way. What you did so far, very quickly, let's go through this because this is part of every data science projects you'll work on. So you'll be loading the data, you will look at what is missing. And once you identify, you have to have a strategy. What will you do with them? Like age, income, and spending scores are numerical field. Education is alphanumeric or categorical is the same data science. So you have to have two strategies. For numerical field, I have imputed by either mean median or next KNN imputer. If it's alphanumeric, depending upon there are again two types. If it's the order makes sense, then you want to put some kind of ordering mechanism around it. And then we did the same here, KNN imputer that works on numeric field. So we first created KNN imputer, and then we imputed the numeric columns here. All right, so let's look at the second question, apply one hot encoding or create dummy variables using Pandas. So if you're familiar with the dummy variables, so what happens, they call it one hot encoding. Let's say, let's see if we can write it down here. If I have values like in a column called gender, the possible values are male and female. So what you really do is you are creating columns like gender male, gender female, and if a row had, let's put a comma here, or I can write it somewhere else. So if you value had, if someone row had a value male is 1 or male is yes, or the gender was male, then you say gender male is yes, and then female is 0. If you saw the female value, then 0, 1. So now in place of having columns like gender male, female, you will have columns like really gender male and gender female. And that happens with something called get dummies. That when you apply that to the column you're looking for, that will create dummy values. And prefix is gender. Data encoded, we encode the data. So here we are concatenating existing data frame with the new columns we created. And that creates like, false true, like, here it is male, so I have value like false, and then, the value is true. Okay, and then let's look at the label encoder. That's like another one. Membership level, if you think basic, premium, gold. In fact, premium and gold, like there's no relationship like given here. So you need to understand the data, how it is. You have really two options. Either you can do what we did for education. You can put in an order. Likely this will makes full sense here. But for now, I'm showing you using something called label encoder. It's part of scikit-learn pre-processing label encoder. To label encoder and set data membership level is, you just fit transform to that value. It generates those values for you. So see, you can see the value is 0, 2, 1. So here, if you use a label encoder, then of course you're giving the control to the label encoder here, which is doing a good job. If you wanted to control that a little bit further, you could have done what we did with education order here. You can also have used exactly the same style. And so that was your label encoding. Very fundamental, very important, very critical. Every data science project you'll work on, you definitely will be using to clean up your data. And then this probably the last one. Oh, there's one more. So it's saying like, if I have data below certain values, then I don't want to consider. If I have value higher than certain values, I don't want to consider. So here you get the first quartile here, and just like, data income, you're looking at the quantile 0.25, and Q3 is quantile 0.75, and interquartile ratio is like a range is Q3 minus Q1. So saying, okay, lower bound is going to be by Q1 value minus 1.5 times IQR, and upper bound is Q3 plus 1.5 IQR. And that's simple. Like, then you say data income, the data I'm looking for, it has to be greater than lower bound and less than the upper bound. And then I go and print the head here. So this will limit your data only for those ranges. The other one, Z-score, is part of the SciPy library. SciPy stats, a scientific computing package. Sklearn is on top of SciPy. So here I said data income Z-score is Z-score data income. It's as simple. That will convert. They'll give you the Z-score, and we did Z-score last time. If you remember, if you haven't done it, just look at the coding challenge number 2, at our website, and you'll find it there. And again, just to remind, how will you go to our website? Like, go to, the website science-technology.net, go to events and meetups, and then go to weekly coding challenges, and then you can go look at, like, challenge number 2 here. Okay. So let's go back here. So we get the Z-score, and then we're saying I want values only between -3 and +3. So saying absolute values for the data income Z-score has to be less than or equals 3, and then we get the head. The last one is for duplicates. If you have duplicates data, what do we do? So what I have done here is I created a new file. So I took the same data and duplicated all those rows. So you can see now I have um, many more. Good line numbers. 31 rows. I have 15. I have taken, like, these remaining, and I have copied them. So you can see one is 125 male is exactly the same. And that way I'm going to look at how duplicate works. So I again, like, import. I should not import pandas because I have it, but I want to read this duplicate CSV, and then you can see data size and data head. All right. So duplicates data dot duplicated, that will give you the list of duplicates, and I will say data in parentheses data dot duplicated. So this returns only true for those rows which are duplicated, and then, like, this gets duplicates. And so if I print the duplicates rows, uh, these are the duplicate rows, 15 onwards. When I said data clean, data dot drop duplicates. When I said dot drop duplicates, and then we'll have the cleanup value. So this is very straightforward. So what I'm going to do is, like, as part of the video, I am going to share the source code I wrote, and also the link to the websites where you can look at the coding challenge every week. I personally think, because I interview a lot of people all the times, you definitely want to keep practicing with these, like, assignments to get better at them. With that, thank you for your time. I really appreciate it. Enjoy coding, get better, and that's the idea behind getting better. All right, thank you. Have a good day.